Have you ever wondered how easy would life be if teleportation does exist? You don't have to worry about gas money, you could avoid busy traffic. But is it possible? If it does, why does we never hear of it? When does the idea of teleportation start? Well, it all started as a thought experiment involving a cat that was proposed by Erwin Schrödinger to prove the possibility of teleportation. To understand the teleportation in detail, let's send the Schrödinger's cat to the moon. Remember, the Schrödinger's cat has the probability of half of it being dead and half of it being alive. So it is in a quantum superposition of A times being dead plus B times being alive. We never knew the state of the cat inside of the box, but we do have the probability of its state. In order to send the cat to the moon, we need an entangled pair of particles, which may work as a portal in a way, where one is here on the earth with the cat and the other one is on the moon. Like an entangled pair of fleas which plays in its own box, which one flea is dead and one is alive since they are in superposition. Entangled particles are the transmission mechanism, as entanglement can be maintained over arbitrarily long distances and they are dependent of each other, meaning that if the flea on the earth is alive, the moon flea state is dead. Then again, we don't know which state is which. And we're going to teleport the cat state of existence to the flea on the moon by putting the cat and the earth flea together in the same box, entangling them in a particular way and thus teleporting the cat state to the moon flea. Since there are so many combined probabilities of the outcome of the cat being dead or alive along with the earth flea also being dead or alive, we would come up with 4 possibilities. The cat is alive and the flea is dead. Then we could write as alive times dead. And to say them in a sneaky and simplest way is the cat isn't dead alone minus the cat and the flea are the same. The sneaky way to write cat and flea are both alive is they're both the same plus they are both different minus at least one is dead. Sneaky way to say cat is dead and flea is alive is they're both the same plus they're both different minus the cat isn't dead alone. And sneaky way to write they're both dead is at least one is dead minus only one is alive. The point of this sneaky indirect questioning is to bring the cat into entanglement with the flea, which what actually teleports the cat to the moon flea. And so, to make the teleportation succeeds, we just need to match the exact probability of the cat earth flea with the moon flea. And since whatever the outcome of the moon flea is dependent on the outcome of the cat earth flea box, then we can absolutely determine the outcome of the probability for the moon flea, making a successful teleportation. But a question arises as why does it call teleportation if we are just sending the state of the cat to the moon flea instead of actually send the cat to the moon? If you view the cat just as a pile of particles, then by quantum teleporting the state of pile that looks like a cat to the blank canvas pile of particles on the moon, we would indeed end up with a cat on the moon that is literally the same cat we started with, though the particles that were originally the cat on Earth would now be mixed up state possible for those particles. In conclusion, it is very hard to make an entangled pair of sufficiently big particles and then make them stay entangled for a long time. As for now, we only succeeded in teleporting a single photon and electron only as far as 100 kilometers. But with the invention of new technologies, we may be able to teleport a cat to the moon in the future.